Artuk, and we're gonna stream some coding today. Buenos dias, доброго ранку. Hey, I wonder if you can hear me well and everything is in place and we can get started with some coding today. Oh yeah, I need to learn Italian. It's also hyvä huomenta if anybody from Finland is watching me. Yeah, good morning everyone. So, while you're letting me know everything is working good, I'm gonna switch the screen and show you what we're gonna do today. Just someone, oh hey Max, good to see you. Yay, it's all good. So today we're gonna be working on this animation from this particular website. Like, it has a lot of animations, but I liked this one. It's a simple one, but we've had some hardcore math derivatives streams, so we're going to be using quite a simple one today. I'm going to implement this one and show you how you can do this. So let's get started. It's a nice one. The thing that I like about this one is that if you move the mouse into the center of the screen, just wouldn't be able to see anything. Gotta be this kind of position where you can't really see anything. Yeah, almost. All right, let's go. So I'll call this animation what? No, that thing. All right. So I'll copy paste my usual template with the 3JS. In the past couple of streams, I think I used Canvas Sketch, but you know, if you follow a couple of my streams, you already know that it doesn't really matter what you're using. That thing. And then I'll use parso to run this one. I'll open the HTML, it's a very complicated HTML, and then the JavaScript. Oh, I'm glad I helped you. Where are you from, Jay? Are you from Romania? It's like name sounds a bit Romanian. All right. So in the template, we have the basic 3JS setup, and we have camera, scene, renderer, all this generic kind of stuff. And the camera is 002 position. And then we have some settings which are disabled by default, but I'm going to enable them. And then I have some weird aspect ratio calculations, which I don't really need at this point, but anyway, India. Oh, okay. And then I have the the basic objects with the shader material, which is using two shaders, vertex and fragment, and well, that's it. And then the request animation frame. All right. So first of all, I need this plane. I need to see that anything is working. Okay, so we have this plane. Well, first of all, I think to implement this kind of how do you call it, perspective distortion, or this kind of view, you can't really use the perspective camera. We would need to use orthographic camera, which is like if you're watching in parallel rays from some distance, but not from one point in the distance like we usually do with the humans. So it's like a projection to some plane. But I wonder if I'd like to see the version without. Okay, maybe I should switch to orthographic projection. So to do the orthographic projection, we just need to set left, top, bottom, right values, like where the camera would look at. And there we go, we have it. And because the frustum is 10, it's too huge. Let's set it to 3. It's going to be almost the same. But you can see that if I'm rotating the camera now, it's a bit different than it used to be before, because this is an orthographic camera. If I switch it back, you would see the distortion right now, yeah. So it's a perspective distortion. Anyway, we need the orthographic camera. Next thing, when we use the orthographic camera, we actually know the exact dimensions we are looking at. So I think if I set my plane object to, instead of 1, instead of 1, 1 to, let's say 2, 2, what's gonna happen? It's gonna be twice as big. And then I think because the frustum is 3, if I set the height to 3, no, I mean if I set the height to 3, it's gonna take the full height of the window, which I don't want actually. Let's say I want 2.8, and then to make it stretch to the other dimension, I actually would need the aspect ratio, and the aspect ratio is let's say I'll save it this far. It's gonna be this aspect, and it's gonna be 3 multiplied by this aspect, right? Yeah, that's right. And then I should subtract something small again, just so it kind of fits, and multiply it again to the aspect ratio. Yeah. So now we have something like this. Maybe divide it. Should I divide it here? It's a bit off. I should definitely multiply it. Okay, let's leave it at that. I don't think that's crucial for this. Yeah, we're making this website, this animation. Just go and look at it. All right. So we have the plane almost fits the screen. Now I'd like to draw something on it. First of all, I need to see the shaders thing. If the shader is working good for me. Let's say I want to see this. Okay, this is red, perfect. I would also need another object on my scene, and I would just go ahead and add this one. So instead of adding another plane, I'll call this one box. I'll say it's going to be using the same material, but the different kind of geometry. Okay. Let's say its size is going to be just 1. Yeah, of course you can contact me. There's, I don't know, yeah, a bunch of ways. You can write me on Twitter, you can write me in the comments, you can write me on the email. I think in the description of each of the streams there is an English contacts. There are. I need some wine. Okay, so we have the box now. It's using the same material, and probably no, it's not there yet. Why it's not there? Because I didn't save this file. Okay, so now we have the cube because it's using the same color. We're not able to see actually anything. But let's switch it to VUVs. Yeah, now we've seen the UVs corresponding to each of the objects, which I don't kind of like, but let's stick with it for a while. And then I need to do something with the UVs, obviously. And what's that gonna be? So first of all, I can do the repeat part. I'll call it repeat part. And then I'll set up the new var, UV equals VUV. And then new UV equals vector2 fract buvx multiplied by, let's say, 15, and then buvy. And let's see how it looks like. It doesn't look like anything because I forgot to put this. So here's how it looks like. So we are just repeating the pattern because we're taking the fractional part of this var. We actually have 15 0 to 1 ranges here. So it goes from 0, which is black, to 1, which is red, and then again. And then we have like small UVs on the screen. This is actually just the simplest repeat you could imagine done with the GLSL, the basic one. But let's say I want to draw lines. So I want to create some function which is going to be drawing a line here. And let's say I want to do it like this. I want it black and white anyway, so I'm going to create the three-dimensional vector out of the result of this function. So it's going to be float line, and then it's UV like that. And then I could just let's say I want something 0, and then u equals what? I want to use step function, something like 0.1 uvx. Yeah, why not? This should work, right? At least it looks good to me. Doesn't look good to the compiler, obviously, because I need to return something. Yeah, now we have the generic lines. They're not actually that good, and it's only because we still have the straight lines, and they look perfectly fine. But once we switch to the angled lines, it's not gonna look fine at all. You know why? Because of the anti-aliasing thing. So what should I do next with those lines? I think I would like to, let's say VY. Let's make something like this. Yes, now you see that the lines are angled, and they're using their own angle actually right now, and they're not that smooth. Well, if I zoom, you could see that it's just not good enough. For this kind of thing, there's an a-step function. I just learned that, well, you could use a smooth step, which I usually used in past, but kind of want to use the new function. It's called the AA step. Obviously anti-alias step, and then it's the same kind of thing, but let's see, is the output any different? It is actually. It's much more smooth than right now. Even if I zoom to the maximal zoom, it's much more smooth. So it looks good right now, but it doesn't relate one object to another. Like, right, they have the different kind of pattern, and obviously they have the different kind of pattern because they have different UVs, because it's two different geometries. How would I connect them to have kind of the same geometry? Well, the first obvious try could be to use the built-in function, which is called glfrag_chord, which is the global. And this one is measured in pixels, so I would need to divide this one by the resolution XY. And let's see, it should actually work. Let's see. No, it doesn't, because why? Have some error. Oh yeah, of course. This is a 4-dimensional thing, and I need to take on the XY coordinates of this one. And what? Add the image is not a function. I need to remove some bullshit from the JavaScript. Here it is. It's the bullshit part. Yeah, no errors. So okay, so I use gel point chord, but gel frag chord, but somehow it doesn't look good yet to me. Oh yeah, because obviously I'm still using the VUV thing here, and I need to switch to UUV thing here. Now you can't see the cube at all, but it's there. If you turn around, you would be able to see the cube. This is actually might be the basic kind of masking of the pattern you would be able to do in JavaScript, just creating some object and using the gel frag chord UVs on this one. But this doesn't do me any good because like anyhow I would rotate the thing, it would just stay the same. Okay, I would like also to create the rotation function. I'll use the simplest two-dimensional rotation, and it should be, it's not the simplest one to me. There gotta be another one. Yeah, two-dimensional rotation. Yeah, here it is. And I'll create the uniform rotation. I'll create it here. I also want to create the line width. Let's say 1. Rotation, let's say 6. And then between 0 and 1 something. And then I want to create those the uniforms for my shader. Then I need to declare them here. And now I could use the rotation thing. So when I'm creating the UVs, I can actually rotate them. Should I rotate them before or after I'm switching them? I think right here. When I have created those, I would need to rotate. So just override the variable with the rotate and UUV rotation. Is it right? It's what I'm rotating, and then the angle, right? Let's see. Because I'm not updating the uniform yet in my loop. Yeah, it's perfectly fine now. I think the rotation angle is too big. Where was it again? Here. Just use MathPy. Yeah. So now we could rotate this thing to any angle, and the cube's still there, but it's not working good. So what do I do next? Obviously the guys are using some kind of noise here. Well, not real here, but if you do the remix, you could actually do the distortion here, and you could do this kind of thing. And this is what I'm going to do now. So I'm gonna look for the JLSL noise. A lot of them. I think I would use the two-dimensional noise. I don't think any bigger than that. Classic Berlin noise. This one looks good to me. Some of them are glitchy, so some of them return -1 to 1 range, some of them return 0 to 1 range. You never know, just like in your life. So this is the C noise, which is using the two-dimensional thing. And then I will calculate some kind of noise. It's gonna be C noise, and then out of what C noise? I think it's gonna be based on the UV, and I think I should calculate it before I'm doing the rotation part and all the other stuff, right? Maybe after the rotation. So I'll use new UV here before the repeat part, because if I do it after the repeat part, it's gonna be just repeated noise. Right, now it's right. I'm gonna use the C noise, and then I could just UV and add the noise there. Let's see how it will look like. Doesn't look good because maybe because of this, or maybe because of some other stuff. Yeah, because I didn't copy the whole function of the JLSL here. This is some kind of broken noise here actually, because it didn't have the permute function, so I'll just copy paste it 3-dimensional instead, even though I don't need these 3 dimensions here. But anyway, this one is called C noise again, and I need to create the vector here, maybe 0. So if I do it in another order, it's gonna be much cooler than that. Yeah, you should just let me know, guys, if you can hear me again. I think my router just dropped, so I'm gonna drink wine for a little while until you let me know that you can see me again. Yeah, I know, right? I know what I have two networks on my router, and one of the networks just dropped. And I had one network on my laptop and another network on my PC. And then only one is working right now. Yay, we are back. Yeah. You never know what will break in your stream. You never know. All right. So I was at the part where I wanted to explain why the noise is not smooth. Because we have all those ranges from 0 to 1, 0 to 1, 0 to 1 again. And if I do the step function, I only take the one part of the range. So if I remove the noise part, if I just remove this part, and then I remove the this part. So I'm just taking this smooth region, but I need to take this one too. To make it smooth, I need to make it smooth from both sides. And right now I'm using step, I'm using just this part. So to do this, I think I need to use the line width again. It's gonna be float, line width. Let's say it's just width. And when I'm using the line, where's the line? Right here, I'm gonna use the line width uniform here. Yeah, welcome back, guys. Sorry about that. So this is the line function. It's not here, it should be here. So when I go into the line function, I'm using the new UV and the line width, and here I would like to use the two sides of the of my range. So this is going to be the width, and the line width by default is actually 0 or something like that, right? It's 1. Let's say it's 0.3. Let it be like that. So here I would need to subtract this. It's just going to be 1 minus width and then UVX. So it should be like that, I think. Let's see what it's gonna return to me. Instead of the new UV, I'm gonna get back to the line. It's actually working fine. I wonder why the further it gets. It's a nice animation you can do with this, with those lines. All right. Let's try this one with the noise now. Still not good somehow. Because why? Let's figure out that. So I have this a step function which make it smooth. Have some kind of rotation maybe. Let's say rotation by default is math pi divided by 2 by 4. It's 45 degrees. Now it's divided by 4. It's still not quite smooth, maybe because the lines are too. Let's try to change that. The line width is not working because I'm not setting it in the uniform. Yeah, they're actually smooth right now, but we have this shitty thing here. So to account for this one, I would just do the conditional inside my shader. Just that the line width was not right. It was 0 or something. That's why I didn't see the smooth lines. So I'm gonna do something like this. If uvx is less than something small, I don't know, like this, then u equals 0. Else if is bigger than 1 minus the same range, then u also equals 0, and then else, this is all the other parts, I'm gonna do it smooth. So this is just to hide the center part. Edit, yeah, less, should be good now. Yes, now we see we remove this part and change the line width and do it cool like that. We can rotate the thing. I think I could also change the repeat. I could do the repeat part, repeat, and then here and then I would need to add the setting here, by default 10, and then from 0 to 100, and then I need to declare the uniform here, repeat. I think I forgot the comma somewhere. It's good now. And then instead of multiplying by 15, I would multiply by repeat. Yeah, so now we can change the repeat. It's kind of cool. And we have those smooth lines, and we can change them in a different way. We can rotate them, but we still don't have this kind of animation. What do we need to do to make this? I think we need to separate. We need some kind of value that doesn't really change when I rotate. So this JFrag chord doesn't do us any good job. What I think would do us a good job is the position, the actual position of each of the vertex. Let's say the position equals position. And then I should have this position inside my fragment shader. I think I have it, but with the wrong type. Okay, now it's good. I can even try to preview this one. Yeah, we have something like a position. It actually looks kind of cool, right? And we have the cube standing out because it has a Z position also, and that's why it's starting to be blue, because X, Y, Z are GP. B is for Z, blue is for Z coordinate. All right, and then we could try to use this V position actually as a UV. Why not? Because we don't actually using UV here, it's just the values we're using for the noise anyway. So it doesn't really matter. So just use V position Y. Yeah, and I need to comment. And it's starting to look good. Like from this angle you don't see anything, but you can even rotate this whole thing. But from this angle you don't see it. There's one small thing though, like this noise is just straight lines when it's getting to the bottom. I don't like it, but to remove this and to make this noise be as something meaningful here, I think we should add the z coordinate to the noise, because otherwise it's just the same on the sides of the cube. And to make it use the z coordinate, I would actually need to use, I think I would add the time here, like something divided by 4, and then the z coordinate. I would use the v position z. It doesn't work quite good. You know why? Because the z coordinate of this side of the cube, which facing us, the viewer, is different than the z coordinate of the other side of the cube. And I think also the time should be much slower than that. Yeah. And to make it the same, what I want to do, I'm going to use the geometry. I think there's a bunch of ways to do this, but I'm going to just use translate. And because the size of the cube is 1, so it's going to be 0.5. Or maybe it's minus 0.5. Let's see. I think it's minus 0.5. Yeah, right now we don't see the cube. We don't see anything. This is a perfect noise facing us. But once we get a bit of an angle here, yeah, because the cube now. Okay, and to move this one, we would need to use this position back again. We should move it back to the viewer again. Z equals 1.2, so it's above the plane. And right now, if we move the camera, we would see this. This is already kind of cool. And I could do the cube like this, not really the cube anymore. But then I would need to change the this side. Now it's perfectly fine, but once we rotate, we would see the angle. Let's try to implement simple inertia and maybe add some font. I don't know if we have to. Yeah. I am the adult content. All right, so it's kind of cool already. And we could play with it. We could change the line widths to something kind of like this view more. Change the repeat part. This looks cool already. So let's try to use simple inertia. I would measure the mouse position. I need the mouse object for this mouse events. I don't really remember what's the name of those events, like what the name of the vars I get in return there. So it's the ScreenX and the ScreenY. Okay. So I'm gonna create two vectors. This mouse equals this mouse target equals this one, and then mouse events. So the this mouse x is gonna be equal to what? Yeah, e screen x divided by this width. So it's gonna be something in 0, 1 range, and this is minus 0.5. It's gonna be minus 0.5 plus 0.5, and then I'll multiply it by 2, so it's minus 1 plus 1, and the same for the y. Height. And then let's just Vector 2 is not defined. Oh, because it's 3 vector 2. Yeah, right. Should be good now. Because mouse events run on it once. And I kind of want it that to run every mouse move. So yeah, on the corner it's something is wrong. It should be between -1 and 1, but it's not. Why is that? Okay, let's just debug this stuff. This is, I think, the most important stuff when you can debug this stuff. If you just can't do this job, it's not good. If you can debug it, this is perfect. So when my mouse is on the rightmost edge, because it's a ScreenX. Oh yeah, this is ScreenX, and this is not. This is actually measuring the mouse position on the screen, on the actual screen, which I don't want. It should be something like a PageX or you know. Yeah, like this. It even said screen to me. Why don't I read the names of the vars? Yeah, now it's right. It's -1 to 1. Right. And then I could of course do just this. I think I would need to move this mouse events a bit here. I would need to set the default values here. I could do this, come on, this box rotation X equals this mouse X. And then the same for the Y. My backspace is not working today. So now if I turn the mouse, but it's the opposite way. It's kind of counterintuitive, but this works fine now. This is not interesting because I need the target and mouse target, and then class equals 0.1 multiplied by this mouse target X. And the same for the Y. This is just to add some inertia. This inertia is too slow. And this one is too big. And I think it's minus. Yeah, now we're using inertia and it's all working fine. And we can do the lines and the stuff. It's gonna be still working fine. When we're in the center, just you can hardly see anything. So let's just add some last thing. And I don't know if we should make it a text. I think it should look cool like a text, and you can write some meaningful words with the text. So I'm gonna just go free text geometry. And to do this free text geometry, we need this thing, and then this add text. Let's try to add text. So loader with 3 font loader, and then we need something like this JSON. Let's call it a font. And then let text mesh equal this material, the same material, and this scene adds text mesh. Yeah, it should be good now. I don't actually need this bevel part. False. font file. Let's call it font file. Because I'm using the parcel, I would need to include this font file before I'm gonna be using it. Import font file from what? Font JSON. Hey, and now I need this font JSON actually because I don't have it yet. I'll go to the 3JS example, and then I think I'll just can check the network tab and all. Let's change the font. I don't like this one. Okay, this one looks good to me. This is the JSON. So it's just font JSON. I'll copy paste all this stuff there. I think there are some converters where you can create your own font. Let's not go into that. Yeah, because parcel need to be restarted probably to find that file. Well, yeah, of course it doesn't need to be restarted, but it needs to know it's a file actually. It's a local file. It's looking at the JS folder. Okay, let's go one up. Unexpected token. Let's just restart all the things. I've never tried actually to load the JSON font with the parcel, so it might not even work. Yeah, I'm still not running the function which is adding. No, I'm running it. What the hell then? Where is my text? Okay, I need to remove the stupid console logs now. Geometry is not defined. So loader loads the font file. Doesn't even load anything. So it loads the JSON as a JavaScript file. And how do you load the URL? I think I could do a stupid thing here. So I could just use this URL. Just like that. And then of course I would get the cross-origin error, probably. Geometry is not defined. Oh yeah, because the geometry is another scope. So I should add it inside the callback. Obviously, that was the mistake. Still not there, but something else probably is wrong. Not read property material of undefined because this is not defined there. Yeah. We can do that. We can do that. Now we just can't see anything. Oh yeah, the text is actually here, and it's with a noise. It's actually looking beautiful with the noise, right? But I need to make it much smaller than that. Size 80, probably I need size 0.4 something. Now we have the hello, and the height is probably too big. I need something smaller. Now we have the font here. Now I think this geometry, because the size is this, it's gonna be this minus 0.2. Something is what? Geometry is not defined. Yeah, because I'm doing it in the wrong place again. Yeah, I think we just nailed that, and then we need to move the text mesh a bit ahead. Like this. Right, so we don't see the text by default, but it's there. It has the angle thin. I would need to remove the there's the better way to center it, but let's write something meaningful. And I would also need to, I think I would rather move it here. You could actually get the size of the mesh and then center it, but who cares? It's the other way. So it's sadness, but because sadness is too short, let's make it a happiness. A happiness fits just fine instead of sadness. And then I could rotate this thing, and I could this text mesh. I would make it a this text mesh, meaning that text mesh, and then here, right here, if it exists, I would do this to it. And then I think I would rather remove this box. I don't really need it anymore. Text mesh is not defined. Probably because I'm adding the text mesh. All fine, no errors. Yeah, now we have the happiness in place and we could rotate it. I think we could make the text bigger than that, like 0.8 for, let's say, and then this one 0.4 for the height. Well, let's leave it at 0.2. Where is the center? I want to see it in the center. I think something is off again because I changed the size. Yeah, it should be twice, probably. I messed up the calculations again. And now it's right. This is right. I wonder what happened when I made it bigger. It's all right. It's all right. And now we have the text. I think the rotations are obviously too big, so I'll divide them by 4. Then I'll change the line width, something cooler. Used to be. Well, the happiness is now too big, right? We need to get back to sadness. This can't be happy, you know, because it's a too long word. We'll just get back to blah. I think that's it. I could, of course, minus 0.5, say, to move it to the center. Maybe I could make it even bigger than that, 0.3, like 1.3. Yeah, well, that's it. We actually implemented this cool effect, and we can change all the vars now, and we could do some other cool stuff where you could see, I think it's too big. This looks the coolest, right? Maybe I made it too small. Yep, here we go. It's not centered and it still bothers me. There is of course a way you need to compute the bounding box of the object and then move it away exactly the bounding x position, but I hate that. I'm a dirty hacker, so I'm gonna just do this and hope that it's gonna be centered. It is. It's a perfect center. No, fuck. Yeah, now it's perfect. Yep, that's it. It's kind of simple, but has some small details here for the implementation, and it's kind of interesting and cool to do this kind of stuff. So actually, this is how it looks from another angle. But when we take that into account all the calculations, it looks cool. Have you heard about something WebGPU? Of course, this is the next API, but I'm not yet eager to try it because I'm still yet to learn the GLSL functions, and I'm just at the beginning of the GLSL and the OpenGL stuff. So I'm not ready to learn something new. It's a bit different because they're using the different kind of language for the GLSL, for the shaders. And the API is a bit different, but I think for the end user, you would be just using the 3JS and you would be just fine. But you would need to learn some new tricks because WebGPU is faster in some ways. Could you show us how it will look if you switch the camera back to... Yeah, exactly. Yeah, that's what I wanted to do. Thank you. Thank you for mentioning that. Yeah. The illusion would break because of the perspective, but let's see. What? So here's how it will look like, right? Like nothing. And why is it breaking actually? I'm not sure. Oh, because I commanded the camera position. Yeah, because of the orthogonal camera, this thing breaks now. I would just need to make it real big, like the real big plane. Let's say, where is my plane? It's here. No, not here. It's here. Okay, just command this one. I'm gonna do 10, 10. It just breaks the illusion, and the further I would get, the less the break of illusion would be. And the closer I am, the more the perspective distortion and the more distortion we have here. But it looks kind of cool. I think I could also add in the shader right here the time. Let's divide it by something, because otherwise it's 10. So it's gonna be a little more alive. Something like that. It's cool anyway. It's cool to play with those patterns and with those distortions. It's kind of a 3D without any lighting, without anything. It's 3D with the where your eye could guess the 3D part. Whew. Well, I hope the YouTube would save this video as a one video anyway. And I'll raise this glass of wine for all of you who've been watching this stream with me, who left even after my internet broke down. Yeah. I'm glad you've been with me today. I'm gonna use this cool animation to switch back to the screen. Hope you're happy. Everybody should be happy. At least sometimes. I'm not sure about your questions, Loibagor. Why do you need the normal matrix for drawing elements? Normals are usually just an attribute, and then you just use it in the shader. I think so, at least, from what I know. Okay, guys, thank you for watching me today. hope you like this simple animation, because sometimes the devil is in the details, and especially in this kind of animation, it's in the details definitely. With all those line width parts, and then the repeat, and then the UVs. It's cool. So yeah, call someone that you love and say them that you love them. Don't forget to contact your closest persons. Do something good today. And I hope you would get something useful from this stream, and you're in a good mood. And have a good day, guys. Just write me on Twitter, write me in the comments if you like some. You can also support me on Patreon. Yeah, I keep forgetting about that one. I still have the Patreon, and you could just go and support me on Patreon. Thank you. Have a good day. Have a good mood. Have a good life. Have a good everything. Bye.